Good afternoon, everyone. Our project is blockchain based question paper security system. These are our teammates. Our project is blockchain based question paper system. We are going to implement a blockchain based secure exam system where question papers are encrypted and uploaded to IPFS. The hash of each paper is stored on the blockchain. We are going to see the step by step implementation of the project. Faculty uploads the paper, faculty logs into the MetaMask, and we have the software requirements. Uploads the question paper to the dashboard. Paper is encrypted by AES algorithm. AES key is stored with RSA. RSA is another type of algorithm. Encrypted file is uploaded to IPFS, which generates hash. The hash which is generated and the encrypted AES key plus timestamp are stored on the blockchain via smart contracts. Access during exam. At exam time, the authorized invigilator logs into the MetaMask. Smart contracts check if the time is the exam time and is the user authorized. If both are true, smart contract releases the decryption key. Then the decryption key, using the decryption key, the invigilator or the faculty need to decrypt the encrypted question paper and needs to distribute through exam center. Every upload, download and access attempt is recorded immutably on the blockchain. How users get benefit on this? Faculty can securely upload question paper without fear of leaks. Papers are immutable once uploaded. Exam officers or invigilators access papers only at the scheduled time. Gets verified access via blockchain. There are no fake users or duplicate users. Students benefit indirectly by having a fair, transparent and leak-proof exams. Eliminates unfair advantage due to leaked papers. University or institution increases credibility and trust. Reduces chance of insider fraud or hacking. Question paper leaks are major issues in universities and exam boards. Traditional storage methods, email, PDF, centralized servers are vulnerable to hacking and insider threats. Such breaches damage the credibility of institution and affect students' future. Blockchain provides a decentralized, tamper-proof and transparent way to secure exam papers. Our system ensures encrypted storage, time-locked access and full traceability of question papers using blockchain. Importance of application. We use this to prevent exam question paper leaks via unauthorized access, to enhance transparency and accountability in examination process, to ensure time-locked release of papers using smart contracts, to provide tamper-proof and immutable storage of exam papers, to build trust among students, faculty and administrators, to offer a decentralized solution with no single point of failure. Related work will be explained by Monish. Thank you.
Hello everyone, my name is Monish and I am here to discuss about some of the works related to blockchain based question paper security system. I have added 6 related works in this PPT and let us see those one by one. The title of the first paper is Secured Question Paper Management System. The main goal of the system is to stop question paper leaks before the exam starts. Let us see what the methodology is used in this system. It uses private blockchain with digital signatures, randomization, and OTACs to secure the question paper lifecycle. Let us see its features. The first feature is OTAC. Provides unique time-sensitive access codes for distribution. The OTAC is like a OTP for an exam paper. To open the exam paper, one must know the OTAC for that exam paper. It is released just before the exam time. The second feature is digital signatures. Ensure the authenticity and origin of the question paper. The digital signature proves that the paper comes from the official exam board and no one has tampered with it. The next feature is randomization. Shuffles question papers to create unique sets for different exam centers. That is, the system automatically scrambles the order of questions for different exam centers. So even if the question is leaked in one exam centers, don't be identical to the question sets in other exam centers. Let us see the limitations of this system. The first limitation is physical distribution risk. Prevent leaks during printing and transit. This blockchain ensures the security of question paper only till the file is opened. That is, the question paper is opened using OTACs. After that, during the printing of question paper and transport, it doesn't ensure the security of question paper. The next challenge is real-time coordination. Ensures simultaneous OTAC distribution and validation across remote centers. This is the biggest drawback of this system. That is, you have to send unique OTAC codes to different exam centers and at the exact same times. This is a major coordination challenge since they are in varying network ranges. The title of the second paper is A Proposed Model for Improving the Reliability of Online Exam Results Using Blockchain. The methodology used in the system is blockchain Moodle integration. Embeds a blockchain model within the Moodle learning management system. That is, instead of creating a brand new platform, it integrates the blockchain system in the existing Moodle, which is used by large number of colleges. Let us see its feature. Moodle integration extends an existing LMS for practical adaptation, just as I mentioned. Next is transaction-based records. Each answer stored as an immutable transaction for full auditability. That is, whenever a student submits his answer, the answer is stored as a transaction in the blockchain. So it cannot be altered, that is, it cannot be tampered with some other answers later. The third feature is wallet-based authentication. Student log in and sign with blockchain wallets for decentralized identity verification. This ensures no plagiarism is done by the student. Let us see the challenges faced by the system. The first challenge is the system enhances the reliability and security of exam results. Its primary challenges are scalability and cost. Storing every answer on chain, especially on a public network, would incur significant transaction fees and could be slow, which may not be feasible for large-scale exams. That is, storing every answer as a transaction on a blockchain is very slow and it is very costly. So it is not feasible for large-scale applications. The title of the third paper is Blockchain-Based Competitive Examination System in India. Let us see the methodology adopted. Comprehensive framework tailored for large-scale exams using a permissioned blockchain with IPFS for decentralized storage of encrypted question papers and answer scripts. The IPFS means Interplanetary File System, which is a decentralized storage system that stores a file and returns its content identifier, which is the cryptographic hash of that file. If the file stored in IPFS storage is tampered, then the corresponding CID will change. Let us see the features of this system. The first feature is context-specific design. It mainly addresses trust and scalability in India's large-scale exams. The next feature is end-to-end lifecycle management. Secures all phases of exam process. That is, from question creation to the evaluation of answers, it secures all the phases of exams. The third feature is RBAC via smart contracts. Enforces strict role permissions for students, examiners, and administrators. RBAC means role-based access control. That is, it specifies what each individual can perform. Example, examiners can only evaluate the paper, or students can only submit the answers. Let us see the challenges faced by this system. The main challenge of this system is that the paper explicitly identifies several practical challenges, including scalability, user adaptation, and navigating regulatory and legal issues related to data privacy and digital records. The title of the next paper is Permissioned Blockchain-Based Remote Electronic Examination. The methodology adopted by this system is e-exam protocol. Uses a public permissioned blockchain with decentralized identity-based verifiable credentials. Let us see its features. Verifiable credentials, privacy-preserving identity management. That is, In this system, a student can verify his identity without revealing his personal details. Next is anonymity via blind signatures. This ensures unbiased grading. The next feature is comprehensive security. It guarantees question accuracy, mark privacy, and test or mark verifiability. Let us see the challenges faced by this system. The primary challenge for this system is the implementation complexity due to zero knowledge proofs and blind signatures. Setting up decentralized identity system with verifiable credentials and integrating it with a permission blockchain requires significant technical expertise and infrastructure. So it requires more cost and technical steps. The title of the next paper is Enhancing Exam Security with Blockchain Technology. The methodology adopted by this system is REAP implementation. It is built with Ethereum, IPFS, and React.js frontend. Secure storage. Encrypted question papers stored on IPFS with hashes and rules in Solidity smart contracts. The features of this system are it uses modern DApp architecture like React, Ethers, and IPFS. Multi-factor authentication strengthens blockchain-based login security. On top of login using blockchain platform, the user need to add a second layer of authentication like OTP. The next feature is formal security audits. The paper states the system underwent formal security audits and testing, demonstrating a commitment to robust and secure smart contract development. It means they hired professional code reviewers to check for security flaws and other vulnerabilities in the smart contracts. Let us see the challenges faced by the system. Since it is using a public blockchain, like other systems, this model faces potential scalability issues, high computational overhead, and the risk of smart contract vulnerabilities that must be mitigated through rigorous auditing. So, new vulnerabilities can be discovered if not audited properly. The title of the final paper is Blockchain Based Secure Online Exam Approach for E-Learning. The methodology adopted by this system is AI and blockchain proctoring. It secures online exams with AI and stores proctoring logs, encrypted papers, and results on blockchain. That is, an automated AI proctor will continuously watch the students through his webcam or microphone to detect suspicious behavior to identify whether he is cheating or not. Let us see the features. The first feature is AI-powered proctoring. Integrates anti-cheating measures for remote exam environments. Next, comprehensive security. Manages the security of both the exam data and the exam environment. Unlike most of the blockchain which ensures only the security of the question paper, it ensures both the security of question paper and the exam environment. The next feature is IP-based login or traffic analysis, suggests additional network level security measures. It means the system constantly analyzes the student's internet connection to identify whether he is using any cheating tools or trying to hide his location. Let us see the challenges faced by this system. The main challenge is the technical complexity and potential intrusiveness of AI proctoring system. Ensuring the accuracy of AI models and addressing students' privacy concerns related to constant monitoring are significant hurdles. That is, constant AI monitoring can feel like someone is spying on us, and there is a risk that AI can mistook an honest person and flag him as cheating, creating ethical and technical challenges. That's it for the related works. Thank you.
Hello everyone, my name is Niranjan and in this part of my presentation I am going to explain the summary of gaps in literature, the problem statement and finally the objectives of our proposed system. Firstly, when we look at existing research, we can see that most blockchain applications are designed for finance, supply chain or intellectual property. Very few works directly focus on securing examination systems or question paper management. This shows a limited focus on education specific security. Secondly, there is no standardized framework in place. Current studies usually propose custom models, but they don't provide a universal protocol for securely managing and distributing exam papers across institutions. Thirdly, scalability and cost are major concerns. For example, platforms like Ethereum have higher cost transaction and limited scalability, making them difficult to implement for large universities. Another gap is the underexplored area of time lock mechanisms. While smart contracts have been widely studied, very few works actually use them for time controlled access to exam papers, which is very important in examinations. Integration with off-chain storage also remains a challenge. Some studies use IPFS or cloud storage, but the secure governance of encrypted exam data has not been completely solved. Next, there are adoption and accessibility issues. Most blockchain systems are too technical and not user-friendly, which makes it difficult for teachers and administrators to actually use them. Finally, there is a lack of real-time monitoring and alert mechanisms. If an unauthorized access through happens, most existing models doesn't provide instant notifications or alerts. So overall, these gaps highlight the need for a secure, scalable, and education-specific blockchain-based system, which our aim works to develop. Now, let me move on to the problem statement. Question paper leaks are a serious issue that harm the credibility of educational institutions and put students' future at risk. Current systems rely on emails, PDF, and centralized servers, all of which are highly vulnerable to hacking and insider threats. Therefore, the problem we are addressing is to design a blockchain based security system that ensures exam papers are secure, tamper proof, and only accessible at the right time. Our goal is to analyze the current challenges and explore blockchain for immutability, apply encryption for confidentiality, use smart contracts for real time logged access, and finally create a transparent and accountable system for examination management. And finally, I will explain the objectives of our system. The first objective is to analyze the challenges in the current examination system, such as question paper leaks, lack of transparency, and insider threats, so that we understand why a new approach is necessary. The second objective is to explore how blockchain can provide tamper-proof process. With blockchain, once a paper is uploaded, it cannot be modified or leaked, which directly improves security. The third objective is to study encryption algorithms like AES and RSA. These ensure that even if someone gains access to the stored paper, they will not be able to read it without the right decryption keys. The fourth objective is to investigate the use of smart contracts. Smart contracts allow us to set strict access controls and enable time-locked release of question papers so that no one can access the paper before the exam. The fifth objective is to develop a complete blockchain-based system that is secure, transparent, and user-friendly, ensuring trust among students, teachers, and administrators. In short, our objectives are designed to address the gaps we identified and to create a such secure and future ready solution for question paper security using blockchain technology. Thank you. And the next slide will be presented by Pratibha. Thank you.
Hello everyone, this is Pratibha. I'll be presenting you the rest of the topic. Let's begin by examining the current methodology used in the question paper management. Traditionally, question paper are managed, manually prepared and distributed. These are stored in the local server and shared with the institution based on the fixed schedules, which this system has been placed in for years, ranging from inside threats to hacking attempts. There are no tamper-proof mechanism, no real-time monitoring, and no decentralized control. This centralized approach makes it easy for leaks to occur, often without detecting until it is too late. The proposed methodology. First, the papers are uploaded to the decentralized blockchain network, ensuring tamper-proof and immutable records. Instead of relying on the local server, we use IPFC for secure off-chain storage with cryptographic ASIC storage on-chain for integrity verification. Accessing the question paper is governed by the smart control with enforced time lock release, meaning institution can only retrieve the paper at the scheduled time. This eliminates earlier access and unauthorized retrieval. Technologies to be used. These are the technologies that we have been using. Blockchain platform like Ethereum or Hyperledger for decentralized control, smart contract for automatic access and enforced time lock, IPFC for storing encrypted question paper, AES and SHA-256 for encryption and hashing, frontend and backend built with HTML and Python, cloud server for hybrid storage and backup, biometric or 2FA authentication for secure use access, and real-time monitoring system. Hardware and software requirement. Hardware requirement: dual core processor, 4G RAM, 50 GB for free disk space. Stable internet connectivity for blockchain and IPFS interaction. Software: Ethereum blockchain and Solidity for smart contraction. IPFS, AES, RSA for secure storage and encryption. React.js for frontend, Node.js for backend and APIs. MetaMask for authentication and for testing and development. Conclusion. In conclusion, the blockchain-based question paper security system offers a future-ready solution to persist problem by integrating blockchain, smart contraction, cryptography, decentralized storage. We ensure security, time lock, and tamper-proof management of the exam paper. This system not only prevent leakage and unauthorized access, but also build trust among students, faculty, and administration. And these are the references which we referred. Thank you.